I'm evaluating a binary classification model's calibration using Sklearn. Calibration. Calibration_curve . The function gives me two arrays. _prob_true and _prob_pred . _prob_true shows the actual average probability of the positive class for different groups, bins, of predictions, while _prob_pred shows the average predicted probability for those same groups. I have a simplified example. _prob_true equals 0.2, 0.5, 0.8, and prob_pred equals 0.1, 0.6, 0.7, . The question is, what does this tell me about the model's calibration? This is a multiple-choice question testing your understanding of how to interpret the calibration_curve results to assess how well a model's predicted probabilities match the actual probabilities. The choices relate to whether the model is perfectly calibrated, well-calibrated, underconfident, or showing miscalibration. This is the overall topic. How to evaluate if a model is correctly representing the uncertainty in its predictions. This is the data I'm using to answer the multiple-choice question. The first array, _prob_true represents the actual probabilities of events in three different sets of predictions, while the second, _prob_pred represents the model's predictions for these sets. Let's examine each set individually. In the first set, the actual probability is 0.2, but the model predicted 0.1. In the second, the actual probability is 0.5, with a prediction of 0.6. Finally, the actual probability is 0.8, and the model predicted 0.7. This shows the actual average probabilities of the positive class for different groups of predictions. For example, the first group of predictions had an average true probability of 0.2 for the positive class. Think of it like this. You predicted many things would happen, and in the first group, only 20% actually did. This shows the model's predicted average probabilities for those same groups. The model predicted an average probability of 0.1 for the first group, 0.6 for the second, and 0.7 for the third. Notice the difference compared to prob_true. I'm evaluating how well the model's predicted probabilities match the actual probabilities. This is crucial for understanding how reliable the model is, not just if its predictions are correct or incorrect. This option asks, is there good agreement between the predicted and actual average probabilities? If the numbers in prob_true and prob_pred were almost identical, this would be true. But we'll see they are slightly different. This option asks if the model consistently underestimates the true probabilities. It does in the first group, 0.1 vs 0.2, but not in the others, making this incorrect. This option asks if there are noticeable differences between prob_true and prob_pred. There are some differences, showing that the model isn't perfectly calibrated, hence this option is correct. This describes the data the problem provides us, the output of a function that gives us the two arrays prob_true and prob_pred which we use to assess the model's reliability. The core concept of this quiz. We are checking how well calibrated the machine learning model is. A well-calibrated model's predicted probabilities accurately reflect the true probabilities. I see that prob_true represents the actual average probabilities of the positive class for different groups of predictions. For example, the first group of predictions had an average true probability of 0.2. The second group had an average true probability of 0.5, and the third group's average true probability was 0.8. This array shows the real-world accuracy of the model's predictions for various probability ranges. This array, prob_pred, shows the average predicted probabilities by the model for those same groups of predictions. Notice how it compares to prob_true. The model predicted an average probability of 0.1 for the first group, 0.6 for the second, and 0.7 for the third. We compare these values to the corresponding values in prob_true to assess the model's calibration. I'd say that this is false. Perfect calibration means the predicted probabilities and the actual probabilities should match exactly, prob_true equals prob_pred. That is not the case here, hence the model is not perfectly calibrated. That's also incorrect. While the differences are small, they aren't insignificant. A well-calibrated model shows a close match between the predicted and true probabilities, which doesn't happen in every case here. That statement is false. Look closely at the numbers. The first group shows underconfidence, 0.1 vs 0.2, but the other two show overconfidence, 0.6 vs 0.5 and 0.7 vs 0.8. It's not a consistent pattern. I believe this is correct. There are clear differences between prob_true and prob_pred. It indicates some degree of miscalibration, although it is not extremely severe in this case. The discrepancies show that the model's confidence isn't perfectly aligned with reality. This describes the type of data we're working with, the output of a binary classification model. In a binary classification problem, the model assigns data points to one of two categories. For example, is this an image a cat or a dog? The output provides us with the probabilities assigned by our model. This tells us that we will evaluate the quality of the model's probability estimations using a calibration curve. Essentially, we're checking if the model's confidence levels, its predicted probabilities, accurately reflect the true probabilities. The core problem is assessing whether a classification model's predicted probabilities accurately reflect the true probabilities. The goal is to determine if the model is properly calibrated. A well-calibrated model will, on average, predict probabilities that match the true probabilities. I'm given two sets of probabilities. Prob_true represents the actual average probabilities of a positive outcome for different groups, bins, of predictions, and prob_pred shows the model's predicted average probabilities for the same groups. Think of it like this. We split up our predictions into groups based on the probability scores. Prob_true tells us the actual average probability of success for each group, and prob_pred shows what the model predicted the average success probability to be for each group. This list gives the true average probabilities within each bin. For example, the first group of predictions had a true average probability of success of 0.2. This list shows what probabilities the model actually predicted for those same groups. I'm now going to analyze how well the model's predicted probabilities match the actual probabilities. I'll directly compare the predicted and true probabilities from each group to see how close they are. In the first group, the true probability was 0.2 and the model predicted 0.1. There is a difference of 0.1, indicating some discrepancy. In the second group, the true probability was 0.5, but the model predicted 0.6. The difference is also 0.1. In the third group, the true probability was 0.8 and the model predicted 0.7. Again, a difference of 0.1. Now, I will evaluate which statement best describes the model's calibration based on the comparison. This is not true because the model's predicted probabilities don't exactly match the true probabilities. This is also incorrect. There are consistent differences between predicted and true probabilities, even if the differences are small. This isn't completely accurate either. While the model underpredicts in one bin, it overpredicts in others. This is the correct answer. The consistent differences between prob_true and prob_pred show miscalibration. We got it. Hey Vamsi, let's dive into this data. We have two sets of probabilities. Prob_true represents the actual average probability of a positive outcome in different groups, bins, based on the model's predictions, and prob_pred shows the average probability the model predicted for those same groups. For example, in the first group, the actual positive outcome rate was 20%, prob_true equals 0.2, but the model only predicted a 10% chance, prob_pred equals 0.1. Okay, so we need to decide which statements accurately reflect how well the model's predicted probabilities match the actual results. The question is assessing my understanding of model calibration using the outputs from a calibration curve, specifically how closely the predicted and actual probabilities align. This is incorrect. A perfectly calibrated model would have _prob_true and _prob_pred values nearly identical for all groups. That isn't the case here. Also incorrect. While the differences aren't huge, they're not insignificant either. A well-calibrated model implies a much closer match between predicted and true probabilities. Nope, this is wrong because, although the model is underconfident in the first group, it's overconfident in the other two groups. This is the correct option. The differences between _prob_true and _prob_pred, although small in this simplified example, demonstrate a lack of perfect calibration. The model is showing some level of miscalibration. The dataset is not explicitly shown but is implied to be the data used to generate the _prob_true and _prob_pred outputs in the calibration curve function. This is the overall task: to evaluate how well a model's predicted probabilities line up with actual outcomes using a calibration curve. This refers to the specific function in the Sklearn library used to compute the calibration curve. It takes predictions as input and returns the _prob_true and _prob_pred arrays. These are the key outputs from the calibration_curve function. As we discussed earlier, _prob_true represents the actual average probabilities of a positive outcome for different groups of predictions, and _prob_pred represents the average probabilities predicted by the model for these groups. I see two lists here. The first, _prob_true, shows the actual average probabilities of a positive outcome for different groups of predictions. The second, _prob_pred, shows the model's average predicted probabilities for the same groups. Think of it like this: we divided our predictions into bins. For each bin, _prob_true tells us the real-world success rate, and _prob_pred tells us what the model predicted the success rate would be. This is the core of the problem. We need to figure out how well the model's predictions match reality, using those lists I just explained. This question asks us to evaluate how well calibrated the model is based on the data. A well-calibrated model's predicted probabilities should closely reflect the actual probabilities. In other words, if the model predicts a 70% chance of rain, it should rain in about 70% of those cases. We will examine the four options provided to determine which accurately reflect the model's performance. This option checks whether the model's predictions perfectly match the actual observed probabilities, which is the gold standard in calibration. I'll determine if the two lists are identical. This asks if the model's predicted probabilities are reasonably close to the actual probabilities. It's a slightly more lenient criterion than perfect calibration. I'll examine if the differences are small enough to be considered insignificant. This option tests whether the model consistently gives lower probabilities than the true probabilities. I will check if the _prob_pred values are always below _prob_true. This option checks whether there are noticeable differences between the predicted and actual probabilities, indicating a poorly calibrated model. I'll look for significant differences in the values between _prob_true and _prob_pred. I see two lists here. The first, _prob_true represents the actual average probability of a positive outcome in different groups, or bins, of predictions. The second, _prob_pred shows the model's predicted average probability for those same groups. These are the key results of a calibration curve analysis. We compare these values to understand how well the model's predictions match reality. For example, in the first group, the true average probability was 0.2 but the model predicted 0.1. I don't see any details of the dataset itself here, only the results of analyzing the model's performance on the dataset. The dataset is what we use to train and then test the classification model. It is important, but its specific composition isn't directly relevant to the problem. This is the core question. Based on the results from the model's calibration, I need to determine which statements accurately reflect the model's performance. This tells me the overall goal of this exercise. We are assessing how well calibrated the model is, meaning how well its predicted probabilities match the actual probabilities. The whole exercise focuses on this. A calibration curve visually represents the relationship between predicted probabilities and actual outcomes, helping us gauge model calibration. The prob underscore true and prob underscore pred values are derived from that curve. I'm evaluating the model's calibration using a calibration curve. A perfectly calibrated model would have prob underscore true and prob underscore pred values that are almost identical for every group. This isn't the case here. A well-calibrated model shows a close agreement, but again, I notice the values aren't quite the same. Slight differences can be acceptable. However, the differences are enough to qualify as not well calibrated. An underconfident model consistently predicts lower probabilities than are actually observed. While it is true in the first bin, this isn't consistently true across all the bins. This isn't a universal characteristic here. This option says the model shows some miscalibration. This is true because the prob underscore true and prob underscore pred values show some consistent, albeit small, differences. This is the correct interpretation.